Electricity is fundamental for our life, as it allows us to transmit energy, command the machines, and many other uses that change everything. When we talk about electricity, we might mention electric current and voltage. These two are essential and are probably the factors we most care about. Let's focus on these two for now. In order to move electric charges, we need to apply a force. This force comes from an electric field, which originates in an electric charge. Here you can see a copper atom. Copper is the most used material in electricity, as it allows electric current to flow very easily. This atom is composed with 35 neutrons and 29 protons at its nucleus, and 29 electrons around it. Neutrons don't have charge, and protons and electrons have opposite charge. As there are an equal amount of protons and electrons, this atom has a net charge of 0. Electrons are around the nucleus because they are affected by the positive charge of the protons, but they don't fall into the nucleus because they have a relative high speed, which maintains them rotating, just like the Earth around the Sun. Notice there's a specific electron that's further from the nucleus than most of the other electrons. This one is called valence electron. The attractive force for this electron is not that high because it is far away. Hence, it can be ripped from the atom very easily by applying an electric field strong enough. Let's put a positive charge near this atom. This positive charge will now attract the electrons and repel the nucleus. But the nucleus won't move because it has a lot of inertia, it has a lot of mass. The valence electron will move towards the positive charge. The other electrons will be attracted too, but they probably won't get ripped from the atom. Now the atom, which will be called atom A, has lost a negative charge, so it has a net positive charge. There's a nearby atom called atom B, which has a 0 net charge. It has 35 neutrons and 29 protons and electrons. As atom A is positive, it will attract the valence electron of atom B. Atom B now has a net positive charge because it has lost an electron, and it will take another electron from another nearby atom. Let's now unzoom. We have a conductor full of atoms. We will only represent one electron per atom, the valence electron, and the nucleus as a single positive charge. Let's put some positive charges in one of the ends. Notice the electrons will start to flow, but there's a problem. See now the last atom, the one at the left. It has a positive charge, and it attracts the electron it just lost, so current stops flowing. We can fix this by adding some negative charges at the other end of the conductor. But we now encounter another problem. The positive terminal is now neutral because it has an equal amount of protons and electrons. Besides, we ran out of electrons at the negative terminal. We just ran out of battery. Let's solve this problem by charging it while we use it. Notice how electrons and protons are continuously being added to the terminals. In the case of the positive terminal, we will always have more protons than electrons in order to maintain an attractive force that attracts electrons. In the case of the negative terminal, we will always have electrons in order to put them inside the conductor. The amount of positive and negative charges we have at the terminals will define the voltage. The more we have, the higher the voltage. The amount of electric charges that pass through one point at a given time will define the electric current, and the electric current and voltage will define the power of the circuit. This happens inside conductors, but with millions of electric charges. Remember to hit the like button and subscribe for more animations.